Hello. So I'm going to be filling in for an exam prep section this week. So I have to prepare for this worksheet. So I thought I might as well just record myself preparing for it, aka doing the problems, since it might be helpful. I also saw that of these three problems, two of them don't have walkthroughs recorded in those 2 years for whatever reason. So also, I guess if you're ever trying out these problems and you can't find the video walkthrough, then this could be helpful. So yeah, that's all. Let's do these problems. Um, I'm gonna I'm doing them for the first time, or I'm doing them for the first time, but not actually because Fa22 was my final, so I've done this like 2 years ago, and then I've seen all these problems. I don't remember their solutions off the top of my head, but yeah, that's a disclaimer. Okay. A parentheses scheme. Um, okay. Okay. Nice. A parentheses scheme. Scheme induced rage. You want to eliminate all internal parentheses, implement or remove parentheses, and it takes as input a scheme list and returns that list with all internal parentheses removed. Okay. So we are giving a nested scheme list as an input, and we want to unnest it. So like ultimately, this is one list, but I have all these nested lists. This is flat, and I just want to unnest the whole list. So really, this problem is just flatten. If you've ever tried that problem before, I think we've had it in the past. I don't remember about this semester. But yeah, it's just given a deep list, I want to flatten that list. So this will be, and then the general algorithm for flatten is given a list of things. Um, so this is a list of three items, right? Even though there's lists inside the list, ultimately this is a three-element list, the outermost layer, if you want to think about it that way. And then it is the case that some of my elements might be nested. So how do I unnest it? Well, I would recurse on it, right? So if I'm writing an algorithm to flatten a list structure, then a nested list is inherently a recursive structure where if I have lists inside my list, then how do I unnest those nested lists inside my list? Well, I just call myself on it. I call flatten on myself to retrieve a flattened list, and then I sort of aggregate that with my um, overall list. So that's sort of the algorithm I'm thinking about in my head. Let's see what skeleton they give us. Of course, we're in scheme, so I can't just do a for loop over 1, 2, 3 and call flatten on everything. We're going to have to recurse, which is okay because we're still going to take the same approach, right? Instead of using a for loop, I'm just going to do something with the car of my list, and then I will recurse on the critter. Yeah, okay. Let's peek at the skeleton to see what kind of structure they want the solution in. So very nice. They've handled the base case for us. If it's an empty list, return nil. Yeah, if there's nothing to unnest. Okay. And then we have a if else. Is this an if else? Oh, sorry. We're in a cond. So if null, return nil. If something else, return something else return this. Okay. So let's look at what options they have here. So I can say if S is a list, I can say if car of S is a list, I can say if cdr of S is a list, or if the cdr is nothing, or if the car is not a number. Probably, is this a list of numbers? Takes a scheme list. Yeah, I don't think we care about, yeah, we don't care about if it's a number or not because, there might be strings, so it doesn't make sense to think about numbers. And then if the cdr of S is a list, I actually forget if nil is a cdr or not. But like, I think like the cdr should, generally speaking, it should always be a list. Again, I don't remember if nil is a list or not, but this doesn't really seem like a useful condition for us. Like, why would I really care if the rest is a list? I think it right, should be a list. If the cdr is null, and is this the only multiple choice option? Oh, we also have this. Okay. Yeah, so I think these don't really make sense. This one is also like, I don't really get how it helps us. So, we can say, is S a list? Well, if S is not nil, then it should be a list, right? So that also doesn't really help us. And then we're left with if the car of S is a list. Okay. And this is actually potentially a useful condition, right? Because as I'm iterating across my list, I want to look at the car and say, are you a list? In which case, I want to flatten you. And if you're not a list, then you're good to go, right? So the fundamental algorithm is I have a list of things, 2, 3. I'm going to look at each item, and then there's two cases, right? It can be a list or it can be not a list. If it's a list, then I want to flatten it. If it's not a list, I will just attach it somehow. And then I have to chain this entire result, chain onto remove paren of the rest of the cdr. That is not scheme. Okay. All right, so I look at each element, and then this is the algorithm I have to apply. And then I chain whatever result this gives me onto remove paren of the rest because I still have to clean up the rest. So really all that's left to figure, we know the algorithm, all that's left to figure out is which case corresponds to which. So I'm also going to look at C here to hint to me which what they have in mind here. So C, I see remove paren on the rest. That's good. I also see cons remove paren of the car of S onto remove paren of the cdr of S. So I'm not actually sure which case is which here. It seems like both are viable. So I'm gonna start here. I'm gonna choose this option and then see if I can construct a solution if this was the case, because this really is the most likely case, right? Because I want to know if it's a list or not. So if it's a list, what do I want to do? Well, I would want to flatten the carve S, right? So I would want to remove paren from carve S. But I'm not done yet because I have to like attach this piece onto the rest of the list, right? So, we have a couple of different list methods. But for example, I know I have like I have list here, I have cons here, I have cdr. So let's think about the expected output of this, right? If I call remove, if car of S is a list and I call remove parens on it, then it should give me a flat list that looks like 1, 2, 3. Would I want to cons this onto another list, right? If I do cons of this list onto, this is wrong because this would give me, this would still be nested. Bad. If I do list of this, like same thing, right? So the issue here is this returns a list, and I need to be able to extend this onto my like the Python extend this onto the current list I'm building. So extend in Python corresponds to append and scheme. So we can maybe use append, although I don't really like append's like pretty rare in this class, so it's not that would not be my first choice, but let's see if we can make append work with this. So this is a list, and I want to append this onto recursing on the rest of my list. Car of S onto remove paren of the rest of my list. Something like that. So again, what are we doing? These are the elements of my list. I look at this first item. Is it a list? If it's a list, then I have to flatten this, which I can just recurse, which I can achieve by recursing. This will return to me 1, 2, 3. And then I'm going to attach this result onto flattening the rest of the list. Makes sense to me. Again, very liberally using the recursive leap of faith here to flatten other lists because I trust the recursive leap of faith. So if B is this case 1 where it is a list, then now I have to handle case 2, which is not a list. So else it's not a list, in which case I would no longer have to remove paren on the car of S. Oh, I see. So this is actually what we were theorizing before, like, oh, is this cons? But as we've talked about, it can't be cons because then it would still be nested. So this can't be the case. Right, so this should be the case where I do not have to call remove paren on the car. So let's get rid of any options where we're doing that. Remove paren on list of the car and the cdr. I mean, listing the car and the cdr would be strange because like here this would end up nesting the list even more, which doesn't make sense to me. Because cdr is a list, so if you list on a list, then it's a nested list. Yeah, also, just none of these are good. Because again, the cases are if it's a list or it's not a list. And if it's not a list, I have to attach this piece onto it, right? And none of these are attaching that first piece onto it. So I know it's going to need to be one of these. It can't be any of these. It can't be this one. Cons, car of S, that looks good to me because I am attaching the piece. And let me just check my nesting, right? I'm consing not a list onto a list, and that gives me a flat list, so no issues there. Remove paren returns a list. Again, I don't want to call list on a list. Bad. And I do not want to call list on a list. Okay. So it can only possibly be this one. All right. Yeah, a bit gambly there to sort of, assume this is true and then see what I could come up with. But we were pretty sure that it was going to be this one. So other than that, I feel pretty good about this solution. So let's move on to the second one. Bedazzled, the scheme pool. Implement make necklist, a scheme procedure that creates a scheme list where each value comes from a given scheme list of beads, and the beads are repeated in order to make a necklace of given length. For example, if make necklace is called with this thingy and the length of 3, then the linked list will contain. Okay. So we're just going to iteratively grab from my bag of beads, right? So until we're at length 3, it seems. So I'm going to grab the first item, I'm going to grab the second item, and oh, they want an even longer necklace, so I will now grab again from the first item. Seems to be what they want. Oh, sorry, just to bring this up, I think in solving this, I heavily referenced flatten. But I just can't remember if we actually went over this semester. So if you're confused when I'm talking about flatten, it's just I guess search up recursive algorithm to flatten a deep list. Okay, back to bedazzled. Right, so each value comes from a given alphabet of beads, and then they are repeated until we hit the target length. Okay, so I know one of my parameters should definitely be length, right? So it seems like we're going to be iteratively, um, we're going to iterate length number of times. So if the length is 3, I'm going to have to recurse 3 times, and then each time, I guess I'm going to have to like adjust my pointer back and forth across my beads. So yeah, definitely some complexity here. I'm pretty confident what this problem does, but let's just make sure. So we're just going to repeat this. We're out of beads, so we repeat. And then, yep. Okay. So so the crux of this problem is that we need to like repeat across this. Which is, very doable in Python if I can just in Python I would probably do this with like an indexer, like start I is 0 and then grab beads of I and then I plus 1 and then if I like is equal to the end, then set I is equal to 0 again. But I guess you don't need to do this. You can use modulus somehow, um, like this, or basically like some wraparound algorithm. So I can keep a indexer, go up, up, up. Once it hits the ceiling, drop it back down. Just like we've definitely done this in some problem. Or you can use modulus. So do we get any? Oh wow, I get to do this all by myself, no help. It's sad. Okay. Is there even modulus in Scheme? Um, Probably. Okay. All right, then let's look at the skeleton. I think for scheme problems, I tend to resort to the skeleton a bit more just because it takes, just because the structure is more rigid. So I try to draw inspiration from the structure they want me to use. All right. So I have a list of beads and I have a length. Well, I know the base case is definitely if length hits 0, right? And I sort of deduce that just by thinking, just by, again, the sort of logic that I have to recurse the length number of times. And how do I sort of remember how many iterations I'm at? Well, in many problems we've done, what we do is we decrement our like target number of iterations each time, decrement, decrement, decrement. When we hit 0, I know that I've iterated exactly length number of times. So if length is 0, it feels like a very natural base case to me. And yeah, I mean, it seems logical because I have this base case, and then if so, I have this rather short line of code here. Else, I have this big mess. So yeah, I'm gonna go with if length of beads is 0. Or no, that's not what I was going for. I was going for if equal length 0. But that does, pose the question, should we ever check if beads is empty? Um, you can assume that length is greater than or equal 1. You can assume there's at least one bead, so I do not care if bead is empty. Or I do not need to, or beads can't be empty. That's the thing. And then another thing we can think about is like, how do I, if these are my beads, and first I take the first item, and then again in Python, wait, we can't index list in Steam, can we? No. Okay. we cannot index list in scheme. So that's the issue. That's the issue with this, right? This is definitely the cleanest way to do this if you were in Python. You have an indexer variable, but we can't do that in scheme. Yeah, so again, in Python, I would just preserve the whole list, right? And then I would just index into the one I want. But here I have a linked list, so I can only access the first item or the rest. So a natural algorithm here would be okay. And in my first call, I'm going to grab the car and I'm going to chain this onto my res, onto my result. And then on my next iteration, I'm going to now recurse on the cdr. So again, I grab the car and now I have the B. And then I recurse on C and I grab and so forth. But then the issue there is like, if I keep mutating my list and I eventually run out of Bs, right? What if target length is 9? In which case, like I need to go back to my A, but I don't know how to go back to it. So is there any other way to do this? Given that I'm forced to mutate my list just by the nature of scheme and by the nature of linked lists, how do I continuously wrap around my list and grab the same items? Okay, I think I know the solution. And I don't know if there's a better way to explain it because sort of the point of making these videos is to, like show how ideas come to me. But like this idea just exists in my head. Like maybe I've done this problem before and I remember, or maybe I've taken inspiration for a different problem. But I think the idea here is that every time every time I go ahead and grab the rest of my lists, I'm not just going to recurse on the cdr, I'm going to recurse on the cdr, but with the A planted at the end, right? And then I'm going to recurse on the cdr, but then I'm going to put the B at the end. And in that way, I infinitely wrap around. Um, yeah, I mean, I don't like that explanation because I want to share what, like how you would derive a similar solution. But this idea just exists in my head. I mean, it makes sense, obviously, but it's just like how would someone come up with that? I don't know. Maybe I guess like the intuition of what I said before. Like I need to keep wrapping around, right? Like even when we had this Python solution, the key intuition is that my indexer I needs to keep wrapping around the list. So I starts at 0 and then it gets to up here, and then once it hits the end, I needs to wrap back around to 0. Same if we did the modulus solution, right? If we did I mod the len, then the moment that I reaches the len, we would mod it and then it becomes 0. So I guess just this notion of wrapping around, maybe, you know, that sparks the idea of I'm going to continuously chain the front onto the end. Yeah, honestly, I don't know if I would have come up with something like this on an exam. Maybe I just remember this from it just came to me. So, yeah, I mean, definitely a tough problem, but I think that is the way to go. So if the length is 0, like, I mean, probably just an empty list. It's usually what it is. Um, Actually, I'm not sure yet. We could come back to that. Otherwise, I'm going to cons again, right? So given that this is my alphabet of items, I want to repeatedly take from the car. Why? Because that's all I can do with a linked list. That's sort of the only thing you can possibly do with a linked list. So, you know, scheme problem should already force you into a particular mindset. So I'm going to cons the car of my beats. I'm going to take the first beat. And then I'm going to um, attach it onto the rest of my necklace that is attainable from the rest of my list. But I think the key here is just that instead of just passing in the coulter beads, I have to be clever and cons, or I can't cons because that would make it nested, maybe append for the same reason as the last question. I'm going to extend this with just like so I want to extend it with the first item. Right. So what happens is I used the bead. I used carved beads, but then I loop it around and stick it at the end so that in the future, um, if our length is long enough, then we would um, cycle back to that item. And then E, of course, is just we're going to decrement our length to indicate that our length has gone down. And then once length hits zero, what do we do? You know, I'm leaning towards just an empty list. So I'm really rusty with scheme. I actually do not remember if nil is a real thing. It probably is. It definitely should be a real thing, but it's just safer. Um, okay, well, makes sense to me. Um, I don't really feel like filling in these blanks, but yeah, this would be my solution. Apologies. Probably not the most satisfying solution because I sort of, you know, the key revelation for this problem, I kind of just said it, but not the most satisfying explanation, but hopefully you can see the intuition. And now that you know the pattern, if you ever solve this problem again, then you should be able to think through it like I did. But yeah, I guess just the notion of wrapping around is the takeaway from that problem. If Fibonacci is so great, um, oh, so many problems. Okay. Each element of the Fibonacci sequence is defined as twice the absolute value of the difference between the previous two elements. Assume that the zeroth element of the Fibonacci sequence is zero and the first element is one. Implement Fib2, which takes in one parameter, a non-negative integer, and returns the nth element of the Fibonacci sequence. Each element of the Fibonacci. Oh, okay. So they're defining their own custom sequence. I was like, this is not Fibonacci. But we're practically just doing some Fibonacci. The fluff they add on top is pretty negligible. Okay, so we're just computing the Fibonacci sequence here and adding some extra math on top. So we're gonna, at every given iteration, I will need to access the last two elements, and then I need to do some math on the last two elements. Wait, actually, this is harder than I thought. How do I do this? So structure they give us is something with n, and then we have lots of blanks. Yikes. Okay, let's express this as a formula. So we're saying fib2 of n is equal to 2 times the absolute value of fib2 plus 1 minus fib2 of n minus 2. Okay. Let's try to map this recurrence onto whatever they give us here. So I see the minus. So this should probably be Sp2 of n minus 1. Order shouldn't matter. What am I doing? Yes. No. Yes. No. Yes. Um, okay, and then of this difference, I have to take the absolute value. Scheme has a built-in abs. Fantastic. And then here I have to multiply by 2. Okay, hopefully this problem is just filling out a formula. Um, yeah, okay, actually, yeah, that wasn't as bad as I thought it would be. 2 abs. 2. And then what happens if n is 0? Well, again, because Fibonacci is ultimately just like a mathematical, it's just a formula, it's just a recurrence. Um, I'm not really thinking too much about how to implement this. I'm just trying to satisfy this equation because I know it's correct. So I'm not really thinking about code. I'm just thinking about math. And they're telling me you know, they're telling me the 0th element is 0. So then that means if n is 0, oh wait, never mind. Never mind. Um, I was gonna say the base case is simply if n is um, if n is 0, return 0, but never mind. They have us return n here. Um, but I see. So a somewhat common pattern when you have like two base cases like this is instead of writing turn 0, instead of this, you can just say um, right. So yeah. So it seems like that's what they want because again, I want to be able to cover both of these base cases. So I should not choose either of these because I need both of them. And this is one way that I can achieve both of those with one line of code. And they give us that. So yeah, hopefully it's sort of a pattern you've seen before with Fibonacci. Okay. So yeah, I guess thoughts on this problem is just um I guess just figuring it out the mathematical relationship between recursive calls and then pattern matching onto what they give you. Um, yeah. Something countdown. The countdown sequence of a number n is a sequence starting at n and descending to 0. For example, the countdown sequence of 3 is 3, 2, 1, 0. Implement the function countdowns, which takes a scheme list of non-negative integers and returns a list, which is the concatenation of the countdown sequences of each element in list. So, okay, so I have to produce this for every single element in the list. Okay, so if I pass in one number, it's 3, 2, 1, 0. if I pass in all these, then it's going to be 2, 1, 0, 0, and 3, 2, 1, 0. Okay. So, okay. So again, I think it's probably helpful to think about a general approach for this. And when I'm thinking about the approach, I always try to think in Python. So if someone hands me the list 201, how do I handle this? Well, I would probably loop through my list. And then for each num, so like right now on iter 1, n is 2, right? So make a result that I'm going to return at the end. And then what I need to do for this n is I need to generate 2, 1, 0. I mean, there's many fancy ways to do this in Python. I can use a range or whatever, but let's keep it simple because I know I'm going to translate the scheme eventually, right? So a natural way to do this is, okay, let's use another for loop. Or a while loop, because what I'm going to need to do is I'm going to need to iteratively decrement my n because I need to get all the values between n and 0. So one way I can do that is I can while loop my n and then decrement to each iteration. And then when it hits 0, then stop. So I can say like while n is not 0, I can say like res data. So is our final output just a flat list? Yeah, okay, cool. They don't want anything too fancy. So I can just append n, right? So n starts at 2. Okay, I'm gonna append 2 here, and then I'm gonna decrement my n. So n is now 1, and I'm gonna add 1 here, and then decrement it to 0, so it's 0. Only thing is, this would stop before it hit 0, so I would need to do like -1, which feels a little weird. 2, 1, 0. And then I think this algorithm works, right? Because now we quit the inner loop and then we go back to the outer loop. Now n is going to be 0, which should just add a 0 by itself. So we're going to enter this inner while loop. While 0 is not -1, I'm going to append the 0. 0 minus decrement by 1 becomes -1. So the while loop quits, gets me back here. So now I'm going to go to my final number, 1, and so forth. All right. So I think this is a very yeah, I mean, I think this is a natural solution if we had all the fancy tools and iteration and stuff. So now we should just think about how I can translate the scheme and, sort of think about what are the fundamental takeaways from this solution, right? It's for each number, I'm going to need to do some iterative process. And well, we can't do that in scheme, so it would have to be recursive. So I'm going to need to like recurse on each element and then attach it onto recursing on the rest of my list. Actually a bit hard because it's like you're doing two things at once. Did they give us helper? They do not give us a helper. Okay. Um, if something is greater than 0, cons car of my list. This is the comment onto countdowns. Else cons 0. Okay. So we ask ourselves, in what case would I want to cons the car, and in what case would I want to cons the 0? Well, based on also this condition versus this condition, it seems that if something is greater than 0, then I would in fact want to Like if my n is greater than 0, then I would want to put it in my list, right? Whereas if n is 0, then I would want to put 0 in my list. So to me, this should correspond to so this should correspond to the case where I'm iterating across my list and I come across a positive integer, right? Because now I need to execute the countdown sequence. And that makes sense to me because otherwise I'm counting as 0. Okay. So if I arrive at a positive integer, I shall cons that item onto my list, but now in my head I'm thinking, okay, now I need to, it's not satisfactory to just to stick a 2, right? I also need to get this 1 and 0. So somewhere here I'm going to need to do some decrementing. And then cons, and then they simply call countdowns. So not much to work with. Well, okay, let's solve this first, right? If the car on my list is a 0, then there's nothing else to do. I simply con 0 onto the rest of my list. So O should be, what is this blank? M. Why is this O and why is this M? A, B, C, D, F, G. M, N, O, P. Okay, I think this should be N, perhaps. So this should simply be, sorry, I just love saying simply, just like in my vocabulary, but very it's very rude. It's not like it's simple. It's just my brain says simply as it's narrating things for no reason. Should just be countdowns on the coder, right? So if I'm iterating across and I hit a 0, then I will put the 0 in my res, but then I just move on. No issue. Otherwise, so M, I'm going to need to do something more complicated. Let's fill out what we have. We say R is the car of the list. Oh, we have another blank here. If our list is nothing, it's probably just nil, to be honest. Okay, yeah, they give it away with the case there. Okay, so we just have to solve M. So this seems like they're asking us to be clever, to be creative here, because I don't just have another for loop where I can iterate through all my numbers. I have to use some other mechanism to generate the sequence of values. And this has to be recursive call. So that, okay, so that constrains this answer to be sum list. And what list do I want to pass forward so that this algorithm works out? All right. Let's get rid of this approach. I think this will be something rather similar to the beads one, right? Where it's like you don't have the tools to have persistent data structures to keep track of a list. I don't have extra control structures like for loops. So we have to be clever and manipulate our list somehow. And in the beads case, what we did was we put the bead we're working with at the end, so I know that one day I'll cycle back to in the future. Well, now, since all this algorithm ever does is attaches the car of the list onto the rest of the list, then the intuition here is that I would probably want to modify my list so that the next time I go grab the car, it will actually be the thing that I want. And what is the thing that I want? It's going to be whatever the car is minus one. All right. So if I'm calling countdowns, so let's first solve a very simple case, countdowns of three, which should return 3, 2, 1. So I have a list three. I look at it, I say it's greater than zero, and then the skeleton tells us that I'm going to cons this three onto something. And here it tells us I have to call countdowns again. Countdowns only takes a single parameter. So like, what do? I have to make a recursive call, and this list has to be something, right? Well, could it possibly just be three? Nope. Infinite recursion. Bad. Could it be the cdr of three? Nope, because then my output is just three. And I want 3, 2, 1. So I know that in the next iteration, they're going to be, again, asking for that car. They keep asking for the car. So I want to pass them a car that would be useful to them. And what would be useful to them was if I gave them a two. So in the next iteration, so I hand them a two at the next iteration, right? And then they look at that two, and they're going to put the two in their list. And then since two is greater than zero, we're going to recurse again. And at that point, we should probably hand them a one. Because again, the only way we're ever adding things onto this list is with cons car. So I know that my clever manipulation has to relate to the front of my list. So I have to pack the front of my list with the things they want. And so I have to do the decrementing for them. So when they grab the car, it's there, ready. So if I pass in one, then the next time they can just grab the one. And then I pass them zero. And they'll say, oh, okay, you've hit zero, so return zero. So yeah, that seems to be the tricky part of the problem figured out. So the idea is when I call countdowns, I have to hand them. So if the car of my list is K, then I want to hand them K minus one at the front of the list. So I'm going to do car list minus one, and I'm going to cons this onto, well, it can't just be list, because then you would hand them this, and then they're going to work on this two, they're going to do two, they're going to do one, and then they're going to work on the three again, which is bad. Could do the cdr of the list. Right, and that makes sense to me because this function is going to be stuck in this case. Right, it's going to keep iteratively chopping down on n until it hits zero. And then only then, once n is zero, do I attach to zero, and then I just move forward. And then I have to make sure that when I move forward, there are remaining elements in the list for me to work on, which is why I need to still put the cdr in. As in, it wouldn't suffice if I just did this. Right? Because then we have a simple input here, but what if the input was 3, 2? Then this would do 3, 2, 1, 0, but then you would never get to the 2. So I have to make sure that I'm Still putting the cooler of the list at the end. And we are good. Yeah. So I think last time I did this, I just stopped the recording here and then started checking my answers, but I am lazy, so I will do this all in one shot. I'm just going to start looking at the answers in the laptop. Laptop to see how I did. And then if you saw here, what I actually did was I found when I did the first question from when I took the course. So I will see if in 2 years I acquired some intelligence. Yeah. So give me like 10 seconds. I'm just going to find the solutions and check them live. List of carvers is good. Append the remove paren carvus, remove paren carvus is good. Is good. Yeah. Yay, I got it right. And then let's see, did I do 2 years ago? List of carvus is good. Man, what is this? What is this? No, I did get this right. Good job. So let's see what I did 2 years ago. So yeah, I mean, admire or look at admire and then pause and just think about like what is wrong. I mean, obviously it is wrong, but conceptually, what is the mistake? Well, the mistake is that this recording is still going. It is. Um, the the issue here is that okay, sure, is that so given that this is a list, right? And then I call remove paren on it, that gives me 1, 2, 3. But like I can't just return this, right? I have to attach it onto the rest of my list, which is why we needed all the additional append and stuff. Okay, great. So you got better. Um, on to bedazzled. Good. They just have nil. I think they're the same. Hope they are. Card beads, the pen, the cutter. Oh, I forgot this, unfortunately. Pen the cutter beads onto cons of card beads. Um, and so what they have is wait, and let me just make sure. So this is right. Okay, so this is the only one in question. What they have is kind of cutter beads onto cons of card beads, explicitly building out the list in the linked list style. Is this the same if I just do list of card beads? Um, I think so. I hope so. I'll double check after the video, but yeah, should be the same thing. So yeah, always if you need to construct a list on the exam, feel free to do it however you wish. I think the final way that you could have potentially written this is if you did quasi quotes like this. I think this also works. Yeah. I'll put in the description if this is not right. They have this same thing, right? Good, good, good. Okay. Nail card list, cons of card list. Okay. All right. That's all. Um, yeah. Tried my best to be very elaborate and um, talking through thought process. Unfortunately, I felt like for the final countdown one and the bedazzled one, like the key breakthrough idea, the chaining onto the end or the chaining onto the front. Um, like those ideas just kind of appeared in my head. It's it's hard to, or I really badly want to elaborate on what contributed to them appearing in my head, but I can't. They just did. Um, but yeah, hopefully it shows that, once upon a time I was, very bad at these problems, and now I get through them a little bit easier. And also, just as you see these problems again and again, you will in fact just remember that, oh, I've done a problem like that before, and it will just come to you. So yeah, maybe that was helpful. Thanks.